Alright, so calculate the DeBroglie wavelength of a soccer ball, which is a rather large item for trying to find the wavelengths. So we're going to get a pretty funny answer. But for a soccer ball that weighs 525 grams, traveling at 72 miles per hour, and we want the answer in angstroms. So this takes care of a couple things for you guys. First things first, we know that we need to turn the 525 grams into kilograms. So 525 grams times 10 to the 3 grams in 1 kilogram is going to give us 0.525 kilograms. Okay, so that's the weight of the soccer ball. Now we need to turn our 72 miles per hour into meters per second. Okay? And the reason you want to do that is because we will be using this formula right here. Let's see if I can get it up. Okay. We'll be using lambda equals Planck's constant over mass times velocity. So this is going to be our velocity. We need it in meters per second. We'll have a mass right here, and Planck's constant, if you remember, is in joules per second, which is the same thing as kilograms meters squared over seconds squared times second, which is the same thing as kilograms meters squared per second, right? Because one of the seconds will cancel. And it's going to want the wavelength, so we're going to end in total in nanometers, in angstroms. So the seconds are going to cancel here, kilograms are going to cancel, and one of the meters is going to cancel, so we'll be left with 1 meter. But that's enough of a tangent. Let's get to it. Okay, so 72 miles per hour. We're going to do this the long way. Take care of my hours real quick. 1 hour is 3,600 seconds. Okay, that's taken care of. 1 mile is 5,280 feet times 1 foot. It's 12 inches times 1 inch, 2.54 centimeters times 10 to the 2 centimeters in 1 meter. And that should cancel our units. Miles, and for some reason, miles, hours, feet, inches, centimeters, meters per second. Cool. Doing the math real quick because somebody didn't plan ahead. I get 72 divided by 3,600 times 5,280 times 12 times 2.54 by 100. I get 32.18688 meters per second. Now I know this looks like a small number, but you got to think about it. You're going 72 miles in an hour, so 32 meters per second. That's about right. All right, cool. So we have our velocity. We got that. We got that. That's a constant. We're solving for this. So lambda equals h over m mv, or u, or whichever one you use, which equals, let me make this a little bit brighter. Planck's constant is given, and that is 6.626 times 10 to the negative 34. Instead of writing joules seconds, I'm going to go ahead and write it the other way, which is kilograms meters squared over seconds squared times seconds. There's Planck's constant. Our mass we determined up here, 0.525 kilograms, 0.525 kilograms times our velocity that we have right there, 32.18688 meters per second. Just for a quick check, just to be safe, let's just do the units off to the side. Kilograms meters squared over seconds squared times seconds divided by kilograms times meters per second. All right, so that's going to be taken care of here and here. That one of those is taken care of. Kilograms, so we'll end in meters. Perfect. All right, so now you plug this in, and we are going to get 6.626 times 10 to the negative 34 divided by 0.525 times answer equals I get 3.9211481114 times 10 to the negative 35 meters. Don't make the mistake of, rounding isn't going to be a big deal here, but don't make the mistake of stopping here. We need to turn this into angstroms, right? That's what it asks for. So 1 angstrom is 1 times 10 to the negative 10 meters. So 1 angstrom, 1 times 10 to the negative 10 meters. Our answer is I could have mathed that, my bad. 3.92 times 10 to the negative 25 angstrom. Right, and then stop right there because of the 3 sig figs right here. Oh, no, I lied to you. We have 2 sig figs right here, so 3.9 times 10 to the negative 25 angstroms. That would be your final answer. Hope that helped, guys. Coordinate is